Hey, what's up? Today we'll be looking at how to build a custom source to image container image in OpenShift 3.11. So we'll be walking through how to build this image. This will be used to run a typical PHP app. So it'll contain Nginx, and we'll be using PHP FPM to run the PHP processes. And this will be again Ubuntu based. So most of the images in OpenShift, they are either Red Hat or some related distribution like CentOS. So I just wanted to do this a bit differently. So we'll be walking through how to build this base image and then test it locally. And we'll import this image into our OpenShift cluster. So I'm running a Minishift cluster over here on my local. So we'll be importing the image into this Minishift cluster, and then we'll be building a new app out of that. So for the choice of the app we'll be building, I chose the Symfony demo app because it's pretty self-contained. It runs the latest PHP, and it sort of demonstrates how you run a PHP application, and it's applicable to most PHP stacks out there. So you can clone the Symfony demo app from over here. This is the Git repo. Uh, so to just do a quick recap of what a source to image build is in OpenShift, you specify a base image for your app, which contains all the necessary packages like PHP and related libraries, and Nginx or Apache. You specify the source code which you want to impose on that base image, and then you provide both of these configurations to OpenShift, and then OpenShift is going to build a new container image for you based on the base source image and then your source code, and you can readily deploy that resulting image into your cluster. So some prerequisites for source image are you need to make sure that you have 2 or 3 scripts which are named assemble and run. So assemble is for how you build the application source code and other packages and pieces of configuration in your resulting image, and run is for running the process which will run your application or container. So think of it as the CMD directive in Docker. So that's exactly what happens behind the scenes. First, we'll go through the process of building the base image. You can see that it's organized like this. So inside the Ubuntu limp directory, you have a Docker file, and then you have an s2i folder. This will contain all the s2i scripts which I just now talked about. There are like 4 of them, but you need to mandatorily provide 2 scripts, the run and the assemble. The other 2 are just extra stuff which makes your image building a lot easier and developer friendly. And this is the test app which I want to test my local s2i images. So you have to make sure that you have s2i installed on your local, otherwise you can download s2i from this location which they have specified over. Once you download s2i from here, it's just a binary. You just place it in your path and you're good to go. And I assume that you already have Docker installed on your local and some OpenShift cluster running so that we can deploy the image which we build. Let's quickly walk through the Docker file first. The label directive in your Docker file is being consumed by s2i to indicate where the scripts are. So in our case, it is in user libexec s2i. This can be anything, but you just need to specify that over here. And the other things are meta stuff like what services you're running, what ports you're exposing, and what are the tags associated with this Docker image, and then some human-friendly description and name and so on. The rest is very familiar. If you're comfortable with Docker, you just install all the prerequisites needed for running your app. So in my case, these are the prerequisites. So this is sufficing for most PHP apps, I guess. And I'm installing Composer because nowadays every PHP app is going to use Composer for building the dependencies. And then you copy over the s2i bin executable scripts into the path which you specified over here, user libexec s2i. And if you recall, you can't run process as a root user inside an s2i image, or for that matter any image which you run in OpenShift. So what you do is you create a non-root user exactly for this purpose, and you give permissions to all the folders and files which this non-root user is going to have access to, like the Nginx logs, because you're going to run Nginx as this non-root user. This user doesn't have any name per se, but then they have a user ID which is 1001. This is some kind of a Linux convention, I guess. And finally, because I'm running a Symfony demo app, I want to run a Nginx configuration which is very, very specific to this. You can probably expose this as a part of your app also, which is a recommended practice, because that makes your image more reusable. I've mentioned this in my blog post as well. So you're copying over this file. Let me just quickly go through what's inside this. This is a typical Symfony applications Nginx configuration. So you're listening in port 8080, and this is your doc root for your web application. So this is where it'll be looking for index.php file, and this is the work directory which I specified in my Docker file as well. It's $home, which is opt app root src, and the rest of the things you can get from the Symfony website itself. That's where I flicked it from. You can repeat the same thing for Apache as well, but I just did it for Nginx because I couldn't find any documentation about how to run Nginx in OpenShift. So I guess this is where I took it from. Yeah, this is the one. I just added some stuff which is specific to my context, like changing the port, the doc root, and then the fast CGI location and all that stuff. So that's about the Docker file, and let me quickly go through what is there inside the s2i bin. Like I said, assemble and run are the two most important things. Let's go through assemble first. Assemble, if you run the script directly, it's just going to print what the image is for. It's called a usage script, which is in the same directory as assemble. So it just tells you what this is all about. You can just print a stream of text here and exit. That's it. So the next thing it does is it tries to restore artifacts from a previous build. This can be used to speed your subsequent image builds substantially. But then you should provide a way to add these or archive these builds when you run it the first time. So for that, we have an optional script which is called save artifacts. Save artifacts just emits a tar archive to the output stream of whatever you want to archive. So in our case, it'll be the vendor directory which is generated by Composer. So we don't want to build it every time. So we just tar it and then emit it to the output stream. So this is going to be captured by OpenShift and used in subsequent builds as build artifacts. So if you ran this correctly and configure your app to pick up the previous archives, it's going to run this part. So and once this is done, it's going to move the application source code. So by convention, this resides in /temp/src. So it's going to copy over that from this folder to your current directory, because I specify a dot because I've already made the working directory as $home in my Docker file. So that's where it's going to land. And please feel free to pepper comments wherever possible, because that's going to be pretty useful in diagnosing if something goes wrong, because it's your custom s2i image after all. So if we have a composer.json, it's going to run composer. I've already installed composer in my Docker file. I think we don't need the if, but I just copied it over from the existing CentOS based Apache PHP image. So that's about the assemble script. And then let me go through the run script again. We run two processes here. We violate the unwritten rule of containers, where you run only one process per container. So I run PHP FPM here as a background process. I give the argument daemonize, and then I run Nginx in the foreground. So it's going to print all the logs in this standard out. So it's easy to debug basically. So this is about the run script. So you're running two processes here. And then we went through the save artifacts and the usage as well. So that's pretty much it. So let's go ahead and build this image. You would build this image like how you build any Docker image. I use this command. I already built the image now. So please feel free to substitute this with your Docker namespace. So once you do that, you might want to test your newly built image with a sample source code. So in our case, it will be the demo app. So let's clone the demo app first. s2i build the source code, and then the image which you have pushed just now, and then the name of the resulting Docker image. So you can see that it prints all the stuff over here. We might get an error. I'll tell you shortly why we get it and how to fix it. Yeah. So it says that the app env is not set to prod. The reason for this is this Symfony demo app is meant to be a 12-factor app, so it stores all the configurables as environment variables inside the .env. But when we try to build the image, we don't specify these variables. So one good way to do that is specify them, which I'm going to do right now. So you set the app env to prod, and then you give an app secret. This can be anything. And I think it's not visible over here. Yeah, so you do s2i build the name of the source package, which is demo. It's over here. And then the name of the image. It's better that you push this to your Docker registry, because we'll be using that in OpenShift cluster later on. It expects your image to be in a public registry. Otherwise, OpenShift cannot access it if it's in your local. And then the name of the resulting image which you want to build, and then the environment variables. So we have app env equals prod, and then app secret equals whatever you want to give. And then we are using SQLite to persist the data. So we give a database URL. I'll probably do a later video wherein you want to use some other database like MySQL. So once we do this time around, it's supposed to work. You can see that it's built successfully. So let's do a test run of the image which we built. The command you use is just a simple docker run of that image. Because we are running it in port 8080, we expose that port and run it. So it's running in the background. If you go to you can see that the Symfony application is running in port 8080. It's in a local. So let's try to translate this into OpenShift. I've already booted my OpenShift cluster. Yeah, so it's a mini shift cluster which is running over here. Let me go ahead and log into this. I just want to make sure that I have the client installed. You can give anything as the username and password because it's a local setup. I log into my local cluster. So I do a get image streams. I've already imported the image, as you can see, but the command you use to import is oc import image confirm. If your import is successful, it's going to give you all these details like when was the last build and so on and so forth. And this metadata it picked up from the Docker file which we went through just a while back. Once you do this, you can see that your image will be listed over here. And you can build an app using this new image now. So the command for doing that is oc new app. So in our case, it will be Ubuntu lemp source to image, and this repo will be the Symfony demo app. I give HTTPS URL instead of SSH because even though it's a public repo, OpenShift is going to fail the build because it's going to expect some SSH related credential like a key or a token. That's the reason why I give HTTPS. Now we can expect this build to fail because I'm not specified the environment variables. So the command to add the environment variables is not -e, unlike s2i, because these are only applicable for ready-made images which are already built. But in our case, we'll be first building using the base image and then generating a resulting image. So use the build env argument over here. So same command. I just give a different name for this. I'm not sure what happened. Okay, I gave the argument wrong. It's a double hyphen. Okay, you can see that it started the build. You can watch the progress over here. So this is your s2i build in action. These are from the scripts which we provided in the s2i bin folder. In subsequent builds, these steps are going to be cached because we provided the artifacts, save artifacts script and all that. So once that is done, you can expose this service using this command. It's going to push a new image with, like it says, 19 layers to the local registry. When I say local registry, I mean the OpenShift cluster's own registry. So it maintains its own registry for storing the s2i images, the app images, and all. This push was pretty fast because I've already pushed the image before. So you expose the app service, it creates a new route. So you do oc get route. And you can see the URL out here. So yeah, that's it. So it's pretty easy to build your own custom image. It can be CentOS based, Ubuntu based, or even Alpine based. If you are a fan of lightweight images, all you need to do is just give these s2i related scripts and then provide what process you want to run, and then slap your source code along with that, and then inject your base image into OpenShift, and that's it. You have your own application up and running. So we'll meet again with a new video next week. Until then, bye bye.